Okay, in this video we're going to look at integration by parts. And again, you should have a printout that you were able to print out from your Canvas account that shows all of these different methods that I'm going over in these videos, along with the process of when to use it. So let's start with an example here, one of the easier examples. Let's look at the integral of x e to the x with respect to x. And if we go through the process and look at this, we can see that this is not going to be a basic. There are no basic forms that have both an x and an e to the x in them. I cannot do a u substitution. And as a matter of fact, what I have are two separate and distinct functions, which really cannot be combined. And in that case, we need to use the integration by parts. In the integration by parts, we're going to pick the u. U is typically going to be the piece that's going to differentiate down to 0, which in this case is going to be x. And the entire rest of this becomes the dv. So you can see what we've done is to define this as the integral of, there's our u, and there is our dv. And in doing the integration by parts, what we see then is the integral of u dv is equal to uv minus the integral of v du. So let's see if we can get our parts here. I've got my u. Let's go ahead and find our du. Based on that u, okay, so based on our choice of u here, we know that the derivative of u with respect to x will be equal to 1. We can then come in here and multiply both sides by dx, which will cancel it on this side, and we get that du is equal to dx. This is another part that we're going to need to use our form here. The last part we need is v, and v by definition. So again, our v is going to be the integral of dv, which in this case is the integral of e to the x dx, which simply gives us e to the x. So we have the pieces and parts we need. That means that when we look at the integral of x e to the x with respect to x, it is going to be, and I'm looking at this formula here, our u times our v, which is x e to the x, minus the integral of v, which is e to the x, times du, which is dx. And so basically what we've done here is we have created a new integral, but notice that the power on the x came down 1. It actually disappeared. And so we have something we can integrate now, and so we get x e to the x minus, and the integral of e to the x is simply e to the x plus c. So this would be the result in the long form. We can also do what's called a tabular form on this particular type. In the tabular form, we pick the same u and the same dv. And we're going to create a table that has 3 separate columns. The first column is going to be our alternating signs column. The second column is going to be our u, and the last is going to be our dv. Now remember when we were up here, and I'll go ahead and circle these in black so we can see them, we picked a u of x. We're going to put that u in here, and then we're going to differentiate it to 0. The derivative of x is 1, and the derivative of 1 is 0. That's going to set up the number of rows in our particular table. Then we'll go over and put our dv, and we're going to shortcut our notation here, and we're just going to use e to the x. When we integrate e to the x, of course, we get back e to the x again, and when we integrate it another time, we're going to get back e to the x. Alternating signs just simply mean plus, minus, and plus. And then we can read our answer directly off of our table, and this is how it works. We're going to come over here and we're going to read across and down. So our first part of our answer is going to be a positive x e to the x. Then we'll come back in, and once again we're going to read across and down. So we get a negative 1 times e to the x, which is going to give us a negative e to the x. And then, of course, can't go down any further, so that's our final answer. And you can see that these two give us the same result. Okay, let's do one more example using the tabular form. Let's try the integral of x squared sine of 2x with respect to x. And again, we can see that this is going to be an integration by parts. Reason being, it's not a basic rule. No basic rules have x's and trigonometric functions in it. U substitution is not going to work here because no matter what my choice of u, I either have extra functions, trigonometric, or extra x's in it. But I do have two separate and distinct functions. Now, since I have a part which will differentiate to 0 on this, I can go ahead and use my tabular form. I'm going to let this be my u and this be my dv. In the tabular form, remember, we're going to have 3 columns. We have our alternating signs, we have our column for u, and we have our column for dv. And we're going to start with our u, which is x squared, and we're going to differentiate it down to 0. Derivative of x squared is 2x. The derivative of 2x is 2, and the derivative of that is 0. That's going to set up the number of rows in our column. Then we're going to take our dv, and that is the sine of 2x, and we're going to integrate it. And when we integrate the sine of 2x, we're going to get a negative 1/2 cosine of 2x. And let me show you why that is here. I'm going to make some space here below this so that I can show you why that is. If I look at the integral of the sine of 2x with respect to x, this is actually the sine of u. And remember, anytime you do a u substitution, you're going to need that u prime. The derivative of 2x is 2, but in order to put that in there, I'm going to need a 1/2. And so the 1/2 is going to carry down, and when I integrate u prime times the sine of u, I get minus the cosine of that u. So I'm going to need that negative 1/2 on the outside. Now coming back up to my table, I need to integrate that again, and using that same thought process, I'm going to wind up here with a negative 1/4 sine of 2x. And then one more time, I'm going to do that integration, and I'm going to wind up with a positive 1/8 cosine of 2x. And let me move my 0 down here. It's kind of hard to get your lines, make sure your lines are completely straight if you when you don't have a ruled paper here, but you need to make sure that they are. So let me put my 0 in down here. Okay, and then remember, we're going to have plus, minus, plus, and minus. And so, oh shoot, I didn't actually give myself enough room. I can actually put my answer in here. I think I'll have enough room. So again, what we're going to do is we're going to read across and down. And so that's going to give me a negative 1/2 x squared cosine of 2x. Then I'm going to read across and down again. That's going to give me a negative 2 times 1/4. That's going to give me a positive 1/2 x sine of 2x. Looks like I can go across and down one more time here. And you got to be real careful with this. It's much easier to do this on line paper, but when I do that distance again, that's going to give me a positive 1/4 cosine of 2x, all plus c. And in order to do this a long way, we would have to do integration by parts twice.